Hi everybody, my name is Elena. I'm a scientific consultant at NIRx, and today here I am joined by Dr. Michael Lurs, who is going to give you an overview of the Satori software. We here are at NIRx, and since 20 years we try to give the best and most easygoing solution for fNIRS analysis. And one feedback that we always receive from our customers is that they would like to have a software that is user-friendly and it helps them in their steps through the analysis. And this is what today Michelle is going to show you. So for this webinar, for the organization, I'm joined by my colleague Alina, who is taking care in the background that everything runs smoothly. And before I start with introducing our guest today, I want to give you some basic consideration for the webinar. So you're going to be muted for the whole length of the webinar. But if you have any questions, please feel free to pass them in the chat, and we will address them at the end, as well as for the questions that were already asked during the subscription to the webinar. The webinar is going to be shared under the webinar tab in our website. And if you have any questions, please feel free to write us at consulting@nirx.net or support@nirx.net. So introducing Michel today here. He studied computational visualistics in Magdeburg, and afterwards he began his PhD at the Department of Cognitive Neuroscience in Maastricht University, which he finished in 2018. His primary research focus is on the advancement of neurofeedback and BCI tools for fMRI and fNIRS. In addition, he works at the company Brain Innovation to build free and commercial software for neuroimaging analysis and clinical application. These are our channels, so you're going to find the recording also in our YouTube channel. And if you want to subscribe to our newsletter, please scan this QR code. Without further ado, Michel, the mic is yours.
Thank you very much, Elena. Welcome everybody. And thanks for your interest in the second webinar of the Satori. We will start with the basics, so covering a bit of the webinar of the first one that we had, since it's already I think 8 months ago. And a lot of things changed over the last month, and a lot of new updates were coming up. But without further ado, I will start sharing my screen. I hope you can see that. And I'll also start my camera so that you can see me. Okay. So let's open the Satori software. This is the version 1 where we left off a few months ago. And since then, a lot of things happened and a lot of developments were made. But one of the most important things that you become aware of these new developments and of these new updates. So every time that you start the Satori software, it's checking in the background if there are new features available and new software available. So you don't need to update in case you see this message, but you are aware that there are new versions available. And before you update, you can always read the release notes. So just click on Show Release Notes, and then you get an overview of the changes that were made in each of the versions. And this includes also the subversion and the sub-minor versions of the specific tools. I will go into detail, but first let's start the update, because we want to go with the latest versions, which is 1.6.4, which will be available next week. So you just press on yes, and then it will basically close Satori and guide you through the update process. So you will see which component you will update, and you basically just go through the whole update. Then it already starts downloading the new features, and this can be just done in the background, depending on your network connection. Let's take a short look at the major changes that were made in the 1.6.2 and 1.6 version while Satori is updating. We have some new features, which are, for example, the spike removal, which is now included. And we will see this in the preprocessing. This is specifically necessary if you do motion correction with the TDDR method. Then we have some interpolations and some correlation features inbuilt. All the details are for the updates are written afterwards, but you can also check the user's guide for more details on these specific tools. Okay. So just assume we have updated the application, and then as soon as we start Satori again, we get the current updated version of the software. It always asks you to accept that the software is not a medical product. This is very important to know. And then you're already in the main user interface. As you can see, the software is in the beginning pretty clean. We don't have a lot of features visible, but let's jump into the most important, and this is the data that you want to pre-process and analyze. So in Satori, to open the data set, you can just use the open button or file open, and this will guide you to the default directory. Here, I will show you some of the data that we used today. So in this case, it's a tapping example, and we have multiple options of data sets that we can load. So in this case, the data set recorded with Aurora includes the fNIRS file and the .NIRx file. So here is no header information or no header that you might know from NIR Scout systems, but we can use the fNIRS if we want. Additional file formats are the header format and the Satori project, so SRI format. So to open the data set, yeah, just select it and open, and then Satori will automatically open the data set directly. What you can see as the first step is each channel event-related average, and the channel is possible to inspect by clicking into it, and then you get basically the time course of the individual channel. To look into a different channel, you just click into another one. There you can just go through the individual channels. On the right-hand side, you see some options to visualize different features. So in this case, for example, visualizes the oxy chromophore, but you can also visualize deoxy at the same time or total. And what you can also do is you can show it with different colors in the central view. To make it a bit easier to view, just keep oxy for now. Below that, you have the different options, raw, OD, and CC. So as soon as you load a data set in Satori, it automatically transforms the data from raw to concentration data so that you can easier look into the data right away, even without pre-processing. And yeah, I can show you here with the event-related averaging already some insights in the data, where you could see that that we see a difference between two conditions. Now, what is the condition? This is what you see in the background. So the time periods marked with a specific color. So blue one, so in this case, is right hand finger tapping, and green one is left hand finger tapping. And there you can just see by eyeballing that in this channel, for example, we have a higher amplitude for the left hand task compared to the right hand task. So just how you look at the data gives you already some insights. And this is also what one of the main features of Satori, that you can really look into detail of the tools. This does also include the properties. So here you have, for example, the number of channels, the number of detectors, short channels and sources, and your sampling frequency and the amount of time points. This is quite handy that you have it available when you need it. If you want to dive even deeper, which we will do in another data set, I just wanted to show it here. You can open the show fNIRS data set, and there you see really what is in addition in the data set. For example, for the stimuli, you see the data for the stimuli is recorded here, and also which stimulus it is. And then you see also the probe information. This is the standard information from the fNIRS file, and you can just browse it and have a look. If you want to get this data, you can just mark it and press Ctrl+C or save the data as it is. This is also true for the whole data that is used in Satori. You can just open it, you can plot the data, but you can also save the data as a CSV, for example. So if you want to extract information from an fNIRS file and just grab it into another format, for example, CSV, and just save it as a CSV and then load, for example, in Excel. Okay, looking at the data is one of the important features, as I mentioned. So we have different views in Satori to look at it. So one is the main view, where you can see really the channel content. And then here we have the 3D view, where you can see the individual sources and detectors, but in addition also the channel that is made up of these sources and detectors. And then you also see these little ones. These are the short channels. They are marked here. They are also directly visualized. And for this data set, we have for each source a short channel as well available. One also interesting design in this data set is that we have crossing channels. So this is a redundant set. This is also why you have here two sets lying on top of each other. But to see this easier, we also have next to the 3D view, a 2D view. So we can access the 2D view here. I just close the 3D to make it easier to look at. And here you see the crossing a bit easier. So these are the two channels that are crossing. And if you want to access them a bit easier, so that depends on your layout, you can do the 2D view tools, enable editing, and then basically move, for example, the channel here. And then you can see that it also moves the channels in this view. So this gives you some flexibility to access the data and look at it in a bit of a different way. But this really depends on your setup. So here, for example, some channels that are crossing, and it's quite handy to move it around. Okay. So other than that, you have different view options for the 2D view tools, but I will show you the more details in the 3D view, because this is actually a bit of more interest. If you want to go for a standard view, you have some shortcuts. So you can, for example, go to different views in the front. So some shortcuts, keyboard shortcuts that you can find in the user's guide that you can easily come back to a certain view. Now here it might be interesting to, in the 3D view, so tools, 3D view tools, to look at some more features of the 3D view. So we see that there are also head models surrounding it. This we can turn off and turn on, but we can also change it to surface, to line plots, loops. In addition, we can move to specific positions, as I said. So if we don't want to use the shortcuts, we can just use the buttons here. And we can go back to this use. And you have different reference labels. So currently it's the 1010. We can also switch to 1020 or no of these. So the view of the data, yeah, you can change. You can really relate it completely show only the brain, for example. Now this is up to you how you want to basically present your data and point it out later on, but this becomes more interesting when we do the analysis. Okay, talking about analysis, let's do some pre-processing of the data. So we can see that the data in the raw form has heartbeat information in there. You can see these frequencies. We are scanning here with 5 Hz, so they're not as fine-grained, but their resolution is enough to see them nicely. And then we can see some artifacts here, some spikes, and some slow drifts in the data. So we want to basically get rid of some of these artifacts. And to do this, we can go to analysis and then go to fNIRS data preprocessing. And this interface changed quite a lot from the version 1 that you might have seen. So we still have a lot of options available, but in the advanced tab, you see more details of these options. If you click there, you will see that there are a lot of different features, and we will just shortly go through them because it's quite important to understand which of these features you can use. So for the channel rejection, we have a two-step approach. One is to mask the channel, basically hiding the channel from the view, and the second approach is to remove masked channels. So with this, you can first see if you really want to accept the rejected channels, so if you agree with the specific parameters, or if not, you can still keep the channels in, and if you really want to remove them, so also from the further analysis, you can really delete the channels and save a new data set without these. So currently we have two methods, the coefficient of variation and the scar coupling index. And you find more details about these methods in the respective publications and in the user's guide. But as a default, we have this coupling in this with a cutoff value of 0.75, meaning all values below that will cause the channel to be rejected. The motion correction includes spike removal and here the temporal derivative distribution repair. These are the default ones. You can also choose the CBSI method, but as a default, we have the TDDR and the spike removal. The spike removal is applied before the TDDR and really just removes spikes from the data, so using specific iterations. And the parameters you can change quite cleanly in this interface. More details on these things are also in the user's guide. But as soon as you apply a method, you can always see the data, so it's not overwriting the originals. So you can always also change the features here and decide for your own if you have a different choice. And then we have different interpolation methods. So if we find a spike, how should we interpolate? And there we have a linear interpolation, cubic spline, and the monotonic, which is the default. Okay, next to the components where we don't need additional information, we also have physiological removal where we, for example, need short channels. So if they are available, you can see that you can use short separation regression using the GLM. And they have different options how you can remove the short channel information, either using the closest short channel, using the highest correlated, or using all. And if you want to, if you have, for example, have a lot of data, like a lot of channels, you can also use the PCA. And before you remove it, you can also look at it. So let's just show the components. So this does the principal component analysis and tells you basically the component that explains the most of the variance in the data. And here, for example, you see that some of these curves also appear during the task period. So you would definitely want to get rid of some of this information. But it really depends on how many channels, short channels you have, which option is the best for you. As a default, we have the highest correlated one because it selects not all the channels, so it does not over or clean the data too much, but it uses the channel that is best to clean for the specific long channel. Then we basically will include the microwave removal in a later update. But the global component regression, which we implement in a bit of a different feature, is also a PCA, but this time on the whole data set. So here you can also show component. This basically shows you the principal component of all the channels combined. So the component that explains also most variance, but here, in this case, from the data. As you can see, this spike that I showed you on one channel seems to be really present in a lot of channels. So if you wouldn't have short channels, it would also be an option to use this option, but with the short channel, we have much more fine-grained information, so we would prefer this one in this case. Then you can do additional temporal filtering. The filter settings are, as default, low-pass Gaussian smoothing and a high-pass Butterworth. You can also decide for a low-pass Butterworth, but there you have to take care that if you, depending on which analysis you do, that you don't introduce too much autocorrelation in your data. With the Gaussian smoothing, it's usually okay. Still, if you wanted to be 100% sure, would also recommend to use no low-pass filtering here. And then, to basically make the data comparable, you can do normalizations. So in this case, it's a default, it's a set transformation. And we apply all of this currently on the concentration data. But you can also apply these methods on raw or OD. But here, for the sake of this this call, we will use the default settings. So I just press go. And then you see that everything is applied. And you look at the data correctly. So we can look at the time course. So we see it's basically a straight line, which is great. And we also see that the heartbeat is basically gone. And we can find nice amplitudes in some of the channels. But what we still want to do probably is to also trim the data in the beginning and end. So there you can use the trim data option. And then we cut before and after the last event. So this trim data is really to make the data in the same length, so especially if you do multi-study. or multiple runs that you want to analyze. Then we apply, and then you see that it's immediately applied and also changing the event-related averages. Okay, so here we have basically two runs of this data set. So let's open the second run. So we open again an fNIRS file. Now in this file, you can see we don't have any event-related averages shown, and this is because we don't have a protocol loaded. But even without protocol, we can do some analysis before we go the next step. So what we have seen already in the first data set is that we have a channel that shows quite nice amplitude. So we can go to the same channel here and, for example, run seed-based correlation. So just right-click on this channel, run seed-based correlation. And this basically correlates this channel with all the other channels. And let's look at the 3D view to see the results. And there we can see that mainly also because we still have not cleaned the data too much, we have a pretty high correlation. But if I increase the threshold a bit, you can see that it's really more focal on one hemisphere. So let's do the same thing on the other hemisphere. Just select the channel again. And do again a bit of thresholding. There you can see that the pattern is more bilateral. And this you can just do by running a short correlation of, on the data and without having the need of specific events in the data set. In this case, we can also add the information. So we go to the event manager. And the event manager is there to fill the time course with content. Here we already have it prepared, so I just load it. And I load the .prt file, which is just a protocol file, and it mainly consists of information, which start time, which duration, and which parametric amplitude I have a condition. Now to get this into the data, I just click apply to dataset, and then you can see it right away. So you can, of course, also adapt the settings here by just clicking in and changing the time, and then you can also save it. But here, since we have already applied it, you can see it here. And something that we have already seen is this with the correlation that we see different patterns depending on the channel. And this we can also see in the amplitude quite nicely. Okay, let's go to our pre-processed data set again, because here we have already done most of the work. To verify what we have seen in the data-driven analysis, we can do here in this pre-processed one a GLM, so a univariate analysis including the data. And since we have two conditions, the right hand and the left hand, we can, for example, set a contrast for right hand, set a contrast for left hand, and with the add contrast, we basically just do multiple contrast analyses at the same time. And we can set a contrast where we check if right hand is bigger left hand in some channels. This is usually enough to get already an idea, but you can add additional conform predictors. So, for example, the short channels, if you haven't done already the cleaning, motion tracking information, a predictor that you have to find yourself, and then you can also correct for serial correlations with some default values that are already predefined here. So let's just assume the default values, press go. Then we can see that it calculates the whole GLM, and it spits out the three contrasts, and we're just looking, we can look at all of them together. So you see they have different colors here in the views. But what we also see is that we have this white curve, which is our GLM fit, and this also already shows the different amplitudes for the two different conditions, so for right hand and left hand in this case. And just looking at these curves and the distribution, we see that for the left hemisphere, we have higher curves for the right hand, and on the right hemisphere, we have higher curves for the left hand. And in the contrast, you can also see this with the blue one, because that's exactly what we are checking. So let's go again to our channel maps and only look at the right where this left, and then see the distribution on the brain. And there we can see basically the channel where this is true, but we can also lower the threshold to see a bit more distribution. And then we can see the left-right pattern right away. Since we have 2 runs, we also would like to do this in a combined analysis, so including the second run. So we have the second run already here, but this one is not yet pre-processed. So in that case, you could go and do analysis of NIRs data pre-processing and click go. But as soon as you have done any change in this pre-processing window, there will be a chance that you select a different setting for the second data set that you analyze. And this is something that you should avoid. So instead of doing this pre-processing in the pre-processing window, if we want to apply it in the same way to multiple data sets, we can just go to the workflow manager. So therefore you click here on the open workflow manager. And the workflow manager is the way in Satori how you can pre-process and some analysis of multiple data sets. Now to use the workflow manager, you might have already seen this in the previous Satori webinar. Now we can see that there are a lot of more information added, and you see that there are a lot of details behind it. So we have raw, OD, CC. So now these all these tools are type specific. That means if I, for example, load raw data, so I just drag and drop it into the file, you see here that there's a raw at the end, so a little raw button. So if I want to apply something with my raw data, I can only connect it to a raw input. So for example, here the channel rejection, I can only connect it to raw. If I, for example, load a CC, there would be no option for me to connect it to raw. This just takes care that perform the specific pre-processing steps on the methods that are really available. You can just delete these types, or you can go to File and Clear. And then we want to basically do the same pre-processing or pre-processing that we have done in the pre-processing window. So as you could see, we can just drag and drop the information, then connect 2 files with each other and create our workflow. So now, for example, we convert our raw data to optical density, and then we could say, okay, I want to do in the optical density, for example, the SCE, which is the SCAD name that is only available in OD. I can apply this here. And yeah, with this, I can go on and connect multiple things. Here, for example, short separation version, just move it here. And the settings are the ones that you've seen in the window before, just the subset of these settings. If you want to run multiple pre-processing steps simultaneously, you can just go, for example, after the regression, could, for example, say, okay, for the one I want to do a short channel, for the other one I want to do TDDR, and then you have basically split it your processing. So you can create a lot of different data sets, and to save these data sets, you can just use the save option, connect it, or this is CC. So even then you can connect it here. So we first do transformation to CC, connect it, and then we basically can save the data. So you can save the data into this loop, but you could also save the data into a parallel loop. Now, which data are we using right now? So currently we have not selected any raw data. So to select one, just open one. And then you can, for example, select the first data set, the fNIRS, just open. And then it will guide through the whole setting. And here at the end, you will, for example, see the final file format. But you can also store the data into a different folder. So now all of these saved in the folder where it's loaded, but you can also use a different directory so that you have a pre-processing directory, for example, which might be handy if you want to do multiple analysis steps. Now I have already predefined the workflow. So I just load the workflow for this example. Now we can see that they are becoming bigger and including more features in the whole set. But you can just zoom in to see what they are doing. But in case that you want to share this data, you can just save it as a flow, for example. And you can share this data with other people that use Satori or the Satori educational version. So you can just open them in Satori, look at them in this way, and then see if all the parameters that you define are the ones that you want to have. And otherwise, yeah, just cross-check with people that everything is set correctly. Well, let me shortly check if we have done the right one. So here, I want to shortly save the data because I've added the protocol, so I've saved the data. Importantly, if I would save it like this, it would overwrite the fNIRs. This is not allowed, so Satori does not allow to overwrite raw data. So it will save a copy of the file. So underscore SRI, save it, and then it's basically there. And now I can go back to my workflow. So you see that these two files are there. So the first one that we created and the second one. So to run the workflow, I just press run. And then you can see which state is currently processed. And you also get an idea of how long it will take. Usually these steps are quite fast. And within a few minutes, you usually have for a huge data set, your analysis done, your preprocessing done. So these files are now there. They are stored here in the underscore Satori. So we can just open the data set. So this is this one underscore Satori. Yeah, and then you can see the data set as a preprocessed data, including the different channels with the parameters that we have just set. Okay, so we are now ready to do the multi-study GLM, so to combine these two runs. For this, I just closed the other windows to make it a bit cleaner. So all the data sets you can open at the same time. So just close them, make it a bit more clean. Okay, the multi-study, so combining different runs, you can do analysis and go to multi-study group GLM. And in here, you see the current run. So automatically it loads the one that is opened in Satori. And it includes the name of the conditions. So this is quite important that the conditions are all available in all data sets. Okay, so let's start with the first data set because that makes it easier. So I open the first one again. So this is the first data set here and the underscore Satori. Okay. Then I go to analysis, multi-study. And now I can add another run, which could be, for example, the second one here. So it's a Satori. And there you can see right and left hand. So we have the same protocols. Otherwise, it would warn you that you have different protocol names. You don't have to add them all manually. You can also, for example, here in this file, just search, for example, for .snirf. And then you get all the files. So you can select all of them, and then it would add all of them together. With this, it's quite quickly done to add multiple files, but you can also load the file. So if I save this, it will automatically include all these details of these files. Okay, now we also want to set here a contrast. So we have again our two predictors. So right hand, left hand, and I do multiple contrast because then I don't have to rerun the whole dialog again. So I can just create multiple of them. Want to correct the serial correlations, and in this case, we just want to create one huge participant. So we just concatenate the predictors, so we get one big chunk of data, and then we can just press go, and it will calculate the whole GLM for us. As an output, you get the text file of the GLM results. So this is really the whole content, but we can look at this also later because this is automatically stored in a text file. But let's look at the data itself. And yeah, you've seen the pattern before, but now we even see that just overlaying the right one. So now we have the right and left, and we can see that this pattern is now much stronger, and yeah, we have much more confidence in our results in the data that we were looking at. So just shortly looking at the results itself. So something that all the settings that we have basically performed are stored in an Excel file. So here, multi-study GLM results. And in here, you can basically see the contrast that you have defined, the predictors, and then you get results for oxy, for deoxy, and total. And then in addition, you also get the contrast results. So the contrast that you have to find here, right bigger baseline, left baseline, and right bigger left. And this you get for oxy, deoxy, and total. And this is all the information that's also available in text file, but here you have it directly available in an Excel sheet, for example. The same is true for the single study GLM. They also get the full content, but here we are now focusing on the multi-study results. Okay, let's open another data set. So we are done with this part, so we can just close this data set. I will just open another one. And in here, we have one data set that also includes, for example, physio information, but the data set itself is quite interesting. I just wanted to show you if a data set is a bit more complex, what you can do with the software to basically define it in a nice way. Now, here in this case, we can see one thing, that some of the channels are just flat lines and some of them are extremely noisy. So we can use the full data plot to inspect this in more detail. The full data plot just gives you the time course of the whole data. And in addition, it allows you to zoom into the data set in more detail. So you can really zoom into individual channels, and then you can drop the data and really look at it in one go. So what we can see is that a lot of channels are having good results, and some of them are really extremely noisy. And in this data set, if you want to figure out why this is, you can basically look at the 3D view, and there you can see that the channels that we're looking at, some of them are really long channels. So they are to be expected that they have quite not a good signal, but you can really directly see that this is the case. So you get multiple options to look at the data and to inspect them, and even with more complex data, there you can just easily access if it's the case or not. Now, another thing that you see in this data set is that we have more colors and more tasks and events in the data set. So this is a thing that you probably will see in your data. So you will have triggers for all the events in your data set. Now we can use the event manager again to inspect them in more detail and to basically take care that we use them in the way that we would like to see them. So here, for example, the duration is set to 10 here as well, but this is not the right duration. In the previous data set, it was the correct one. Here, the data has the duration of 16. So we could change this individually one by one, but we could also go to durations and just say here 16. That's okay. And then you can see it's filled automatically. Now we don't need the rest condition, so we can just remove it. And then we have two conditions here. This is the start condition, so it defines the start of the experiment, and this is the end condition, which defines the end. So this is something that is in this data set quite helpful, because now we can use this information, so we apply it. And now we can use the trim and basically trim before the first event on time and after the first event on time. If we do this, you will see that we cut directly front and back part. You can see. And now we can remove these two triggers again. So we are done. So we trimmed our data set to the accurate time, and we removed all the information that is not necessary for our data. Now, if you run the standard preprocessing, just don't do some more of the features, you will see that a lot of these channels, especially the long ones, are gone. Yeah, but they are, as I said, not really removed from the data, but just hidden from the data. So to remove them, you go to analysis and remove. which is asking you if you really want to save them in a file. So here we call it score RCM. And then Satori will save a new data set, which only includes the channels that are not hidden, as you can see now. This you also see here on this view, that now a lot of channels that were in there before and are now basically removed. And from the preprocessing, yeah, we can see now that we also get a nice href response. And since we know that the event-related average was a bit longer, it was 32 seconds, we can adjust it here. And then you can nicely see the response in the data, which is directly visible by eyeballing. Now, one of the interesting factors here in this data set is the physiological information. And in Satori, you have some options to dive into the data. And here, especially, the physiological is of interest. So this is all recorded with the wing system from NIRx. And it includes the ECG, respiratory, skin conductance, and heart rate, temperature, and SpO2. So to look at the respiration, you just click on the respiration and select the data. And here you can, for example, just plot the data. And Satori will automatically add the condition information in the background. So the data set is much higher resolution in time, but Satori automatically resembles the information. And what you can now see, which is quite interesting, that we have for the task conditions that we have a different pattern for the respiratory signal compared to the rest condition. You see that we have a higher amplitude, but lower breathing rate in the rest condition, and faster breathing rate and a lower amplitude in the task condition. So just to give you a glimpse of something that will come in the future in Satori is including these information into the GLM as regressors. So after some preprocessing, just highlighting that this is even including information that you wouldn't see directly in short channels, for example. But this is also true for the ECG signal. There you can also just plot it, and then you get the whole of the extent of the ECG signal, and you can just zoom in into specific parts so you can really see the ECG. And if you do, you get a good recording, you really get nice data. This is completely not pre-processed, so something that will be of interest. Okay, with that, I would like to close and give you some time for questions. So stop sharing.
So thank you so much, Michelle. I see that we don't have any questions in the chat, but if you would like to ask any questions, please feel free to switch on the camera and just ask. You can unmute yourself. We received some questions during the registration, and I think we can start with what data formats can be imported into Satori and what files are saved.
Yeah, so we support the main formats from NIRx, so the header, the .NIRs are included, and the .SNIR. And Satori now mainly saves in the .SNIR format, meaning that you can directly load the exported files in another software tool and do some other analysis or some other preprocessing. And the same way you could load data from a different tool in Satori because it's using the SNIR format.
From your perspective, would short channel regression in the pre-processing step be preferred over including it as a predictor in the final GLM? Are there any concerns about using short channels in both steps?
So that's a good question. The problem that you could end up with is that you do overfitting. So basically fitting the data again in the GLM, which you have already removed. So it depends on the fact how you pre-process your data. So if you have done the pre-processing of the short channels before, for example, filtering, then you do filtering and you might want to include the short channels again, but in a filtered version. That would be a difference in the data. But if you use exactly the same information, you would just reduce your degrees of freedom and not explain any variance in your data set. So doing it twice in the same way is you shouldn't do. So either preprocessing or as confounds. But if you change the data from preprocessing, so short separation regression preprocessing to the statistics, then you can add both of them, because it might be that the preprocessing did a change in the short channels.
Then is it possible to do resting state analysis with the software?
Yeah, so some of the features that I showed you were the seed-based correlation, which is of interest for resting state as well. Then we have still the cross correlation of the channels and also the anti-correlation. But there will be more features in the version 2 which go more into the resting state field. Also autocorrelation removal. Yeah, but these are the main features right now.
Thank you. And I think the last one is, how does the spectrum work in Satori?
Yeah, so you can check the real detail or all the details in the user's guide. In short, it's basically an iterative approach. So it detects over time the standard deviation of the signal and detects events where this specific window of standard deviations, the next time point has a bigger standard deviation than the threshold that you have set. And this is the basic feature, which is just with the iterations, which you can then repeat. So this is also important to have the option to repeat it, because if you remove a spike, then of course the standard deviation of the new one will be to be reapplied. But yeah, more details are in the guide, or you can always drop us an email if you want to have more details.
Perfect. So this was our last question. So if there are no other questions, I would like to thank you again. And we provide a trial version of the software that is valid for 30 days. So please feel free to send us an email at consulting@nirx.net. And thank you again, Michelle.
Thank you.
Have a nice evening, everybody.